Good evening, viewers. Welcome to MouShauk. Today, we'll be studying with the Boyle's Law and Charles' Law. Okay. So, before I start, I will request you to please to subscribe my channel if you have not subscribed yet. And if you are a new viewer to my channel, if you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And also, do meditate before you start your day. So before we start our discussion, let us meditate for just 1 minute and then we will start with the discussion. Okay. So for meditation, let us concentrate on a point of light. Think that light is falling on you. You are getting energy. You're feeling relaxed. Feeling good. You can do a lot of work. You're getting interest in your work. You're completing your work very fast, using more time, and at the end of the day, you're feeling happy, and successful. And so, you're thanking God to be inside at your side every moment of your life. So before we start with the gas laws, that is Boyle's law, Charles' law, and gas equation, later on we'll discuss the gas equation. So first today we'll start with Boyle's law and Charles' law. So first we will, these are the gas laws which we will be studying, and Boyle's law is the first one that we will study with. So what is the importance of Boyle's law? Why do we need to study Boyle's law? So actually, Boyle's law helps us to in our daily works, daily life. That is when we breathe, when we walk with a syringe, that is when we get some injections, or somebody is giving us injections, or in when we are using some soda bottle, or when we are painting with the spray painting, that is when we are doing spray painting. At these times, these applications of Boyle's law is needed. Okay. Then when we are blowing a balloon, that time this application is also applied, the Boyle's law is applied. Then when when we are going to mountains, this Boyle's law is applied, it's required. So first, we want to know what is Boyle's law. We need to know what is Boyle's law. Boyle's law is when a volume, when a pressure, when temperature is constant, keeping temperature in constant, volume of a given mass of dry gas is inversely proportional to the pressure at constant temperature. Okay, so volume of a given mass of dry gas is inversely proportional to its pressure at constant temperature. That is, temperature being constant, volume of a given mass of dry gas is inversely proportional to its pressure. Okay, this is Boyle's law, and this was found by Robert Boyle in 1662. At that time, what did he do? He, at keeping the temperature constant, he decreased the volume of a fixed mass of dry gas. Mass was fixed, temperature was fixed. By keeping that mass fixed, the volume he decreased by half. When he decreased the volume of the dry gas half, into half, then he found that the pressure increased to 1/4. Sorry, pressure doubled. Pressure doubled. Okay, so pressure became double. When he decreased it to half, the pressure became double. Okay. And when the pressure he decreased by 1/4, then what had happened? The volume became 4 times its original volume. Okay, 4 times its original pressure he decreased by 1. Pressure decreased, volume increases. So volume increases how much? 4 times it increased. The pressure was decreased by 1/4 and the volume increased by 4 times. So this was found by Robert Boyle. Now we find that the Robert Boyle, he deduced a relation between volume and pressure. Okay, volume and pressure. So for this, so to know Boyle's law, first we need to what? We need to the relationship between pressure and volume. So to know Boyle's law, we need to know the relationship between pressure and volume of the gases. So for this, let us take an experiment. Okay. We take a syringe and we have a piston over this inside the syringe. Okay. It has some weights and its nozzle is dipped into a rubber stopper. So the first, what do? We take the syringe and the piston is raised to about 10 mm. So 10 mm mark it has been reached. And at that time, an adhesive tape is wrapped over its nozzle. Here is the nozzle. We wrap a adhesive tape here. Now the wrapped nozzle is fitted tightly into the hole, which is halfway through the rubber stopper. So we need to wrap an adhesive tape over its nozzle, and the nozzle is fitted tightly. The wrap nozzle is fitted tightly into the hole, and that nozzle will be halfway bored into the rubber stopper. Now, when we put some weights on the one by one, we put some weights on the piston. The piston will move downwards inside the syringe. Okay. So, what do we do when we are pushing the piston inside? We are decreasing the volume of the air which is inside the syringe. Okay, we are decreasing the volume of the air inside the syringe. We are increasing the pressure, volume is decreasing. By increasing the pressure, putting on weights on the piston, so that means we are increasing the pressure, and by increasing the pressure, we are decreasing the volume of the syringe. Okay. On putting more weights, the space of the air inside the volume that is present in the air, that will be decreased more. But when we are removing the weights one by one, the pressure will be released. That is, pressure decreases and this piston will move up. That is, increasing the volume of the air inside the syringe. Okay. So what is the conclusion of this experiment? Is that at constant temperature, pressure increases. If the pressure is increased, volume will decrease of a dry gas. Okay. Conversely, at the constant temperature and mass of the gas is fixed, then when the volume is decreased, the pressure is decreased. Okay, or volume is increased, pressure will decrease. Okay, at constant temperature, if pressure increases, volume decreases. Okay, pressure decreases, then volume increases. Conversely, if the volume is increased, then the pressure decreases. So this experiment proved the relationship between volume and pressure. That is, they are inversely proportional to each other. This experiment, this relationship was proved more I mean, this was proved by Robert Boyle. Okay, he found that this, I told you before that when he reduced the volume to half, the pressure doubled. And when he reduced the pressure to 1/4, the volume became 4 times. So like that, he proved this experiment right. Okay, and therefore he deduced the Boyle's law that they are inversely proportional to each other at constant temperature. Temperature should be constant. Now, mathematically, if V1 is the volume of the gas occupied and the P1 is the pressure of the gas, then V1 will be inversely proportional to P1. Or you can say V1 is equal to K by P1. Or P1 V1 is equal to K, or that is equal to constant. Okay. Now, if V2 be the volume of the gas occupied, then P2 be the pressure of the gas, then V2 will be inversely proportional to P2. Or you can say the same way, V2 is equal to K by P2, or P2 V2 is equal to K equal to constant. So we can say that P1 V1 is equal to P2 V2 is equal to K at constant temperature. And this is known as Boyle's law equation. Okay, and if when we are solving the problems, then if one P1 is not given and the other variables are given, that is V1 is given, P2 is given, V2 is given, then we can find out P1. Or V1 is not given, that is one of the variable is not given, the other 3 are given, then we can find out the one that is not given. Okay, so from this Boyle's law equation, we can say that other way around, that the Boyle's law is the product of the volume and the pressure of a given mass of dry gas at constant temperature is constant. Okay, the product of pressure and the volume of a given mass of dry gas at constant temperature is constant. Okay. Now, the graphical verification of Boyle's law is that it can be verified by some plotting a graph. Okay. The first is V versus 1 by P. Okay. So if y-axis is V, that is volume, and 1 by P is x-axis, then at constant temperature, we will see a straight line passing to the origin. Okay. And V versus P, if it is done, V is y-axis and P is x-axis, then we will see that it is a hyperbolic curve in the first quadrant. Okay, and this is at constant temperature, or you can say at isothermic condition. At constant temperature means isothermic condition, we will see a hyperbolic curve if V versus P is plotted. Okay. Then if it is PV versus P, PV is on the y-axis and P is on the x-axis, then we can see it is a straight line which is parallel to the pressure to the x-axis. Okay. Now, we need to have an explanation of the Boyle's law in terms of molecular motion or kinetic theory. Okay. So, according to the kinetic theory of gases, number of molecules in a given mass of the and the average kinetic energy possessed by the molecules will be constant. So according to kinetic theory, the number of molecules in a given mass of a gas, in a given mass of the gas, the number of molecules present, that and the average kinetic energy that is there inside the molecules of those molecules, inside those molecules, that will be constant. So when the volume of a given mass of dry gas is reduced to half of its original volume, then V2 will be equal to half into V1. V1 be the original volume. Then the number of molecules we know that is same. Okay. So, and their average kinetic energy will be also same. But the space for them to move will be half the original space because volume has been reduced to half. So volume is reduced to half means the space in which they are moving, that is reduced to half. Okay. So in that piston experiment, you can see that, when we are putting much more pressure on this piston, the volume of the air inside here, inside this syringe, that will be less. It reduces. So the space inside which the molecules are moving, that will be reduced, but the number of molecules are the same there. And their kinetic energy is also same, but only the space inside which they are moving, that is reduced. Okay. So, excuse me, the number of molecules striking at the uniform motion, unit area, they are striking at the unit area on the walls of the container at a given time, that will be doubled. Because space is less. The molecules have the same number of energy, same amount of energy, and the number of molecules are same. So they will strike the container more fast. Their times will be increasing of striking the walls of the container. So that will get doubled to its original number of molecules. What the original number of molecules are striking, that times will be more. So that will increase what? That will increase the pressure. So if the pressure of the original pressure is P1, then after reducing the volume, the P2 pressure will be 2 into P1. That is, the pressure will be double. Conversely, the volume of a driven mass of a gas, that is V2, if it is increased, if the volume is increased to twice, that is, if it is say 10 ml and the volume is increased to 20 ml, that is, it is increased twice, that is, space is increased where the molecules, the number of molecules are same, they have the same amount of kinetic energy, but they get the more space, their space is doubled, so they will move in a slower space. Their movement will become slow. Okay, because they have to travel a long distance to hit the walls of the container. Okay, so at that time, what will happen? The pressure will be reduced because the number of times they will hit the unit area of the walls of the container, that will become less. So that will reduce the pressure on the walls of the container, and that will be reduced to half because the space has been increased to double. So their times of striking the walls of the container, that will be reduced to half. Okay, so the pressure will reduce to half. So P2 will be half of P1. So from this, we can find out that if pressure increases, volume will decrease at constant temperature. Temperature should be constant and the mass should be fixed. Okay, so that is Boyle's. Clear? Now, what is the significance of Boyle's law? We know that if pressure increases, volume decreases. So gas becomes denser. Okay, when volume decreases, gas becomes dense. Okay, at constant temperature, density of the gas is directly proportional to pressure. So what happens? If pressure increases, volume decreases and density of the gas increases. So pressure and gas, that will be directly proportional now. Okay, pressure and volume, that is inversely proportional. But as volume decreases, pressure increases, therefore pressure and density, that will be in direct proportional. Okay, so density of a gas will be directly proportional to pressure. So atmospheric pressure at high altitude where the space is more, the atmospheric pressure is low, and therefore the density of the air also is low. Air will be less dense. Okay, and that's why what happens, a less dense air will have less amount of oxygen for breathing. That's why mountaineers have to carry oxygen cylinders when they go to the hills, to the mountains. Okay. So application, we know the spray pens, soda bottle, breathing, working with a syringe. Working with the syringe, we told you about the relationship with the pressure and volume. So breathing process is also the same, that when we are breathing in, okay, or rather when we are breathing, say when we are breathing in, we are taking in more oxygen. That is, air is inside, more air is inside our lungs. Okay, that means the density of air inside our lungs is more. As the density of air inside our lungs is more, the volume will be, the pressure will be more inside our lungs, and therefore what will happen, the volume inside our lungs will be reduced. The molecules of air inside our lungs, that will move very uh, less space it has to move fast. So that is they will move inside the lungs. Okay, and when the and what happened, and when this lungs will have more pressure, it will it will have a tendency to move out. And if there is a leakage inside the, when when there is a outlet, they will have a tendency to, the molecules will have a tendency to come out of the lungs. When they are coming out of the lungs, when the air will come out of the lungs, the volume will be, the pressure is released and the volume will be increasing, and the air comes out. Okay, the air comes out and the volume will increase and the pressure will be released. So that helps in breathing process. Okay, I think I've explained you. I mean, you have understood what I'm going to tell you. Okay, then soda bottle is also the same thing. Soda bottle, when we are pressing the bottle, okay, that will release the pressure inside the bottle, and while releasing the pressure, the volume will increase and the soda will come out of the bottle. In the spray paint also, when we are pressing the spray, okay, we are pressing the spray, we are applying more pressure. But as soon as we are releasing the spray, then it will, there is a hole through which the pressure will be released, and what will happen, the volume, the pressure will be released and the volume will increase, and the spray paint from the spray bottle will come out. Okay. So this is the application of the Boyle's law. Now we come to the Charles law. Okay. So for Charles law, we will have a relationship of temperature and volume. Volume and temperature. Here, pressure is remaining constant. So first we need to know what is Charles law. So Charles law is volume of a given mass of a dry gas is directly proportional to its absolute Kelvin temperature if the pressure remains constant. Fixed mass and pressure remaining constant, volume is directly proportional to its absolute temperature. Now, what is the significance of Charles law? Why do we need to study the Charles law? Okay. So, we know that volume is directly proportional to temperature, according to Charles. Okay. So, when pressure is remaining constant, volume is increased, or rather we say, let us say volume is decreased, the temperature decreases, and when temperature decreases, the density becomes more. Density also decreases. When temperature decreases, density decreases. I'm sorry. Volume and temperature, these are directly proportional. But when temperature is increased, then density decreases. Okay. The temperature is increased, then volume, volume increases and density decreases. Okay. And when temperature is decreased, then volume also decreases, but density will increase. That's why hot air is filled in the balloons that are used in meteorological purposes. And then in winters, basketball shrinks outside in the ground. In the cool, dry, the pressure in the car tires to be checked. Why? Because in cold days, what happens? The pressure in the car tires, temperatures are low. So what will happen? Temperature low, volume will be less. Okay, volume will be less, the density will be more. Okay, and therefore, what will happen? Volume will be less. That means what? Pressure is more. Okay, and then what will happen? If pressure is more, then the car can burst. Then it will not be able to move its, the tire can burst, car tire can burst. In winters, basketball shrinks outside in the ground. When if it is basketball is kept outside in the ground, due to the temperature, low temperature, the volume of the basketball that will shrink. That will reduce. The volume will be reduced of the basketball will, the volume of the basketball will be reduced. Then hot air is filled in the balloons. That means what? Temperature is more inside the air of the temperature of the air inside the balloon is more. That will increase the volume of the air inside the balloon. Okay, that will make the density less, and therefore the balloon will rise up, and it can take the, it can serve the meteorological purposes. It can take the photos. It can reduce the climate, the weather. It can give the weather reports. Okay, so these are the significance of Charles Law. That's why we need to study the Charles Law to find the application of meteorological purposes, to find the why the basketball swings inside when it is kept in the ground, that is in the playground, playing place. We need to know the significance of Charles Law. Then when we are driving a car, we need to know the position of the tires, the pressure of the tires. So for that also, we need to know the Charles Law application. Okay, so for this, we need to know the Charles Law. And for knowing the Charles Law, first we need to know the relationship between temperature and volume. Okay. Now, if we keep an inflated balloon in the bright sun, okay, if we keep an inflated balloon in the bright sun, it will burst after some time. Why? Because in the bright sun, the temperature rises inside the balloon, the air inside the balloon. The temperature will rise inside the balloon, and what will happen? The air inside the balloon that will expand in volume. So as temperature increases, the volume will also increase, but the pressure remains constant. And again, if we decrease the temperature inside the balloon, then the volume also will decrease at constant temperature. So that's why it will burst. Now, temperature and volume relationship are studied by, who studied this? We studied by Jacques Charles. Okay, and it was extended later. The study was extended later by Joseph Gay-Lussac in 1802. And according to the experiments, with the pressure remaining constant, a fixed mass of gas, of any gas that will expand or contract respectively by 1/273 of its original volume at 0 degrees centigrade for each degree Celsius rise or fall in temperature. For each degree rise or fall in temperature, the gas will expand. Temperature for each degree rise, the gas will expand 1/273 of its original volume. If the for each degree fall in temperature, the gas will contract 1/273 of its volume at 0 degrees centigrade, pressure remaining constant. So this is Charles' law. So we now know what is Charles' law. What is its significance? Why do we need to study the Charles' law? What is its application? And for this, we need to know the temperature and volume relationship. Then we will be able to know the Charles' law properly. Okay. So mathematically, we can express that uh, V0, if it is the volume of the fixed mass of a gas at 0 degrees centigrade, then V will be the mass of the, V0 is the volume of the fixed mass of gas at 0 degrees centigrade, then V is the volume of the gas at T degrees centigrade, and P remaining constant, we can say that V is equal to V0 plus V0 by 273 into T. T is the temperature. Okay, V0 is the volume of the fixed mass. V0 by 273, I told you that it will change, it will increase by 1 by 273. So V0 by 273 into T. Okay, so we can write it like this if when P remaining constant. Okay, so P is equal to V0. We are taking V0 as common, therefore 1 plus 2T by 273, or you can say V0 is equal to V is equal to V0 into 273 plus T by 273. Okay, or you can say V0 is equal to, V is equal to V0 by 273 T, capital T, where capital T is equal to 273 plus T. This 273 plus T is taken as capital T. So for a given mass of gas, V0 by 273 is constant. Okay, so V is equal to K into T. K is constant, K into T, or you can say V is directly proportional to T, or VT, V by T is equal to K. So that is Charles' law. We told you that the volume of a given mass of a dry gas is directly proportional to its absolute temperature where pressure remains constant. So for this, we get a Charles equation. If V1 is the volume of the gas at T temperature, at 0 degree temperature, and T1 is the temperature of the gas. Okay, sorry. V1 is the volume of the gas at T1 temperature. T1 is the temperature of the gas, and V2 is the volume of the gas at T2 temperature, which is T2 is the temperature of the gas. Okay, so therefore V1, according to Charles' law, V1 is directly proportional to T1, where V1 will be equal to K into T1, K remaining constant. So you can say V1 by T1 is equal to K, or if we change V2 is directly proportional to T2, therefore V2 will be equal to K into T2, V2 by T2 is equal to K, or you can say V1 by T1 is equal to V2 by T2 into K. K is constant at constant pressure. Okay. So according to the equation, if T1 is T2 equal to T2 and V1 is equal to 2V, so T1 is equal to 2T, that is T1 is increased to twice. T1 temperature is increased twice, then V1 will also be increased twice. That is, if temperature increased twice the temperature, if it is increased double, if the temperature is doubled, the volume will also be doubled. And if the temperature is made half, okay, the volume will also be half. So graphically, it will be represented like this. That is, volume if it is on the x-axis, y-axis, and temperature on the x-axis, then we can say at constant temperature, constant pressure, that is isobar condition, there will be a straight line passing through 30 degree if the temperature is, and it will be 30 ml will be the temperature volume. If the 30 will be the ml, 30 ml will be the volume, it will pass through that, and it will pass through temperature will be minus 273 degrees centigrade. So at minus 273 degrees centigrade, at constant temperature, the volume will be 30 ml. Okay. Then the volume will be 0. So the volume will be 0 at minus 273 degrees centigrade, and at 0 degrees centigrade, the volume will be 30 ml. 0 degree centigrade, volume will be 30 ml. At minus 273 degrees centigrade, the volume will be 0. Okay. Now, temperature, if it is volume versus temperature, and P1, P2, and P3 are there, the graph will be showing isobars extending backward, showing absolute 0 point. This is the absolute 0 point, which is minus 273 degrees centigrade. Okay. If the pressure, the isobars are there, P1, P2, and P3, if the different pressures are there, but they will meet at the same place at absolute 0, which is minus 273 degrees centigrade, and that is as 0 point, absolute 0 point. Now, explanation of the Charles law in terms of molecular motion. According to the kinetic theory of gases, the average kinetic energy of the gas molecules versus its absolute temperature. Okay. So, kinetic energy will be directly proportional to this absolute temperature, that is minus 273 degrees centigrade. When temperature is increased, the molecules, they move faster. They will strike the walls of the container more frequently and vigorously. And therefore, if the pressure is constant, the volume will increase proportionally. Okay, so the temperature remaining constant, the pressure remaining constant, the temperature is increased. So if the temperature increases, they will gain more kinetic energy. They will strike the walls of the container more faster. Okay, so their kinetic energy is increased, the temperature increases, the kinetic energy increases. They will vigorously and more frequently, they will strike the walls of the container more faster. And that will increase the volume proportion. So at constant pressure, volume of a given mass of gas is directly proportional to its temperature. This is known as Charles' law. Okay. So now we know the significance of Charles' law. Okay. So this much for today. We will discuss in my next video about the gas equation, absolute zero. All this we will come to in the next part of the chapter. Okay. So till then, go through the chapter. If you have any doubts, please do write in the comment box. You can also write in my email ID, that is kasturi74@gmail.com. You can write about any other questions regarding any of the chapters I have discussed with you in my videos. Okay, so you can do that. You can get the links of the other videos, other chapter videos in my description box. And if you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And if you have not subscribed yet, please do subscribe. If you are a new viewer to my channel, then also do subscribe. Okay, so that you can get the notification as soon as a new video is uploaded. And don't forget to meditate before you start your day. Okay, and also do maintain a chart so that you can have a track on your progress of your studies. Okay, so thank you for joining and have a good day.